Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video, we'll talk about variables. We'll look at what is a variable, how we can create a variable, look at the shape, data type, and see how we can assign values to a variable. And finally, we'll look at naming and how to turn gradients on and off on the variables, and also how you can selectively place a variable or a tensor either on a CPU or a GPU. So let's get into Colab notebook and start coding. Here, the first item we need to do is import TensorFlow. So I'm going to that import TensorFlow STF, and the very first item we'll look at is how to create a variable. Create variable, and the syntax is similar to what we have seen before for a tensor. For tensor, we created a tensor by writing tf.constant, and let's say we have a tensor with values 1 to, then that gives us a tensor. Now for variable, we can create a variable name. We can create this x underscore variable, and then we can write tf dot capital V variable, and within parentheses you can specify then a tensor. And so what we then have is a variable. So as you can see, it now says tf dot variable, whereas earlier we had tf dot tensor. And then the shape, a data type, and rest of the things are the same as the tensor. Now, another point to note is that a variable also in the backend it also has a tensor. So we have this numpy array in the backend. The variables can be of different types. So similar to tensor, we can have a variable. So x can have booleans as variables. So boolean variable equal to tf dot variable, and here we can have true, false, true, and when we look at the output variable, here we see that it's a variable with shape 3, and the data type now is boolean. Additionally, there we can also have complex numbers. So x underscore complex variable. Here if we create another variable with complex numbers, as uh, 1 plus 2j, maybe 5 plus 4j, and run this complex underscore variable. So as you can see now, the data type is complex 1 to 8, and it is still a tf dot variable. Now similar to the tensors, we can check the shapes for a variable as well and create a few. Okay. So for checking the shape, check shape, data type, and convert it to a numpy. For checking the shape, we can write x underscore variable is equal dot shape, and that gives us the shape of the variable, that is tensor shape 3. And just for reference, you can see the output of the variable here. So this is the variable we have, and it has a shape of 3 because we have 3 elements in here right now. Next, we can also look at the data type of the variable x underscore variable dot dtype, and So in this case, we have data type 32, and additionally, we can also get the numpy array out of it, x y dot y, or we can say we can convert it to numpy array. Is again the data type is still integer 32. Now here we have seen how we can check the shape, data type, and convert it to numpy. Let's now look at if we can convert a variable or reshape a variable. And we know that uh, tensors can be reshaped, but variables, as we'll see, they cannot be reshaped. So have our variable x variable, and let's create one here. X variable is f dot variable, and give it values 1, 2, and 3. So that's our variable. Print x underscore variable and type x variable. So that's the variable we have. Now, if we try to reshape it to, or maybe we can have 4 values there. If we want to reshape this to a 2 by 2 variable, we are going to get an error. So z is equal to tf.reshape x underscore variable, and if we try to get it to a shape 2 by 2, then print type 2 type of z. Now what will happen is variable, because it cannot be reshaped, when we are trying to reshape a variable, what would happen is instead what we get in output is a tensor. So this was the variable. So let me type z, and here let's just type the entire z. So as you can see, we have the x variable. It is a variable, but when we look at z, it has become a tensor. So variable cannot reshape it. So it is as is it is right now. And if we try to reshape it, it gets converted into a tensor, as we can see here. Next, let's see if we can assign new values to a variable. Assign. So x, let's say x is equal to tf.Variable, and here we have the values, same values, 1, 2, and 3. And now if we what we can do first is assign, change the values of 1, 2, and 3 to a different values. So if it's type x.assign 10, 11, 13, and then if we look at the values for x, we should see the updated values. So as you can see, the values have now changed to 10, 11, and 13. Copy this and print the original variable as well. So let's call this orig and x. So the original variable is a variable which has the values 1, 2, and 3. Then the assign, after we assign the values 10, 11, and 13, we get we get the values 1, 2, 3 changed to 10, 11, and 13. Now there is another way we can assign the values. So let's look at how we can do that as well. So let's create tensor y is equal to tf.constant, and here let's have values 55, 66, 77, And now if we assign x.assign y underscore tensor, then what we should see is that the values 1, 2, 3 are changed to 55, 60, and 70, as we can. And again, the output is still the data type. Uh, it is the object is still a variable as we started out with. Now, one point to note here is that if we change the shape of the tensor or the array that we are trying to assign to a variable, if it is different than uh, what what exists in the variable, then we'll get an error. I type x dot assign, and within this, now if we uh, create a variable here, variable, and let's say this variable just has two values, 99 and now if we try to assign such a variable to x, we get an error, cannot assign value to variable 0, and that's because the variable shape 3, which is the one we start out with, 1, 2, 3, and the assigned value 2 are incompatible. So the assigned value would be this one. It does not match, the shapes do not match. You have one element. So that's something to keep. Next, let's look at how uh, variables work as as we saw earlier in assigning the variables. We can do that. There is another way we can use the assign statement, which is add and subtract. If we have a variable x, call this add. We have variable x, type tf.Variable, then 1.3. We can use x.assign add, and here we can add new values to the existing variable 300. Now when we look at the values for x, we should get 101, 100, 202, and 300. That's how assign add works. Similar to this, there is another way to assign, which is subtract. And for this, we can simply write sub. When we run this, we should get subtracted values. So we get minus 99, minus 198, and minus 297. So that's how we can use assign and assign add, assign subtract with the variable. And point to note is that in the backend of variables, we have tensors that are working. Now let's look at how we can name a variable. And this is different than creating a variable such as what we saw earlier, creating a variable x. Uh, Name a variable, and points to note here are that two variables can have the same name, and TensorFlow automatically assigns names, so we do not have to do it manually. Here I'm just showing this as an example. So first let's create a tensor x, tf dot constant, and give it some values 1, 2, 3. Now let's name this. Use this tensor to create a variable with a name. So x is equal to tf dot variable, and use the tensor we create above and name it. Let's call it cool. Now if you look at x, we see that this is the variable, and we now have the name of the variable written here. Interestingly, what we can also do, we can use the same name for two different variables. So let's call this name, and let's create a y, and here we can say tf.Variable x underscore tensor, and change the values of x. We'll multiply them by 10, and we can name this again cool, and this is perfectly okay. So if we now look at x and y both, so if we print x, and then if we print y, then we see that both of them are valid, both have the same name, and but they have different values within it. So this has 1 2 3, this has 10 20 and 30, and we can also check the equality conditions. So if we look at is x equal to y, and we'll see that they are not equal because the values within the retain is not equal to 1, and so on. Next, let's look at how we can turn off and on the gradients for or differentiation for variables. Gradients or variable, and if you do not know what gradients or differentiation is, we'll be covering that in subsequent videos in the series. In briefly, what this tells us is uh, the slope of a curve, and we need that to find the learning rate, for example. And so that tells us how fast or slow we need the learning to progress while the model is training. So the very first item we'll do here is create a tensor. X tensor is equal to tf.constant, and have it 1 2 3. Now to turn off gradients, by default this will be on, so any variable can be used to calculate differentiation, to calculate gradients. But in some cases, such as mentioned in the docs, the step counter, in those cases we do not need differentiation or gradients for a variable, that can be turned off. So to do that, we would simply type tf.Variable x underscore tensor trainable is equal to false, and so that would turn off the uh, gradients for that particular variable. Now finally, let's look at placing variables and tensors. Placing variables, tensors. What we what I mean by placing here is, do we want to use a CPU or a GPU for particular task or storage when we are working with variables or tensors in TensorFlow. So first we'll look at a case where we'll use a CPU to perform the operation. So we can choose a device. So with tf.Device and on this CPU 0. So with this device, what we want it to do is create variable, and the variable would has 1 2 and 3, and then we have a tensor. Again, tensor can be, let's create a 2D dimension. Add 4 there. Then copy this, paste it here, add zeros, and now we can get the dot product. tf.matrix multiply x comma y, and now when we print z, get the output of z. So here what we did is we manually set the device for TensorFlow CPU when it was creating the variable x, tensor y, and the calculation for z. If if the computer does not have a GPU, it will automatically do is on a CPU. But by default, the TensorFlow will automatically choose the best possible device to perform a particular task. If it has a GPU and if the variable sizes are large, maybe it will automatically switch for faster computing. Additionally, we can use multiple devices. So let's say if this, copy this, and for some reason we need to store this particular variables on one device, and then we need to perform the calculation on another device. So we could do that as well. Now in this case, on the Jupyter notebook, I have not turned on the GPU, so it will still run on a CPU. But if the GPU were turned on, then this particular step of calculating the dot product would be performed on a GPU, whereas the part of creating the variable and tensor would be performed on a CPU. And so when we run this, we get the same output. So that was it for this video. I hope this video introduced you to what are variables in TensorFlow, how to create variables, and kind of get an understanding of how tensors work in the background, the backend of variables. Additionally, we looked at examples where we can uh, assign values to a variable and how the gradients could be turned on or off for the variables. And finally, we also looked at how TensorFlow provides us with uh, this unique ability to choose a particular device to perform a set of tasks. So look at how we can assign CPU or GPU using tf.Device. If you have any comments or suggestions, please let me know in the comment section. So I hope to see you all in the next video. Please like, share, and subscribe. Thank you.